Hello ladies and gentlemen, my name is Decryption and I hope you are well. This is currently my fourth attempt at recording this video because I am currently having RAM issues, which is of course the best time to have it. Thank you global markets. But yes, in today's tutorial we're going to be carrying on with our hide and seek example. Last time we made a scene where the AI can run around and hide from the player. In this version we're going to make the player hide from the NPC. So let's get started. So in this version, what we already have, if you followed the previous one, the AI that runs to a location and hides away from the player. If I run up and spot the AI, they'll notice we've spotted them and run away, like so. We absolutely need to go into fixing the proper AI perception up, so they physically see us not just from behind them, but that's something we're going to do in the next part. In this part, we're just going to make it so the AI runs to each location and checks for the player. We're going to do a very basic line trace check for now, but we're going to replace that with the real AI perception in the next episode. So thankfully, we actually almost have everything we need already to handle this. We just need to make some small modifications. So one of the key things we're going to do is take our existing EQS query system here, and we're going to modify it so instead of going from wherever the player is and finding a spot where the player can't see, we're going to make it find all the spots the player can hide, so the ones where it would technically be invisible to the NPC in the middle of the game. We're going to make them run up and search there. But we're going to add one extra part to it to make it just more realistic. We're going to make them randomly go to it. So he might say, oh, I'm going to come here. Oh, he's not here. He might be over there, but I've got a feeling he's over this one. He'll run to over this one kind of thing. But we don't want him, when he's here, to randomly go back to that one. He's already searched it. So we're also going to give him a small bit of memory where he can remember where he's been. And then he doesn't search it. And that way, when we run out of searches, we can successfully turn around and say, okay, come on out, I can't see you. So it's actually really, really simple. So I'm going to come and open up our existing EQS query for our hide from player, and I'm going to duplicate it, and I'm going to call it seek player. So seeking the player, trying to find them. And I'm going to open it up. So for the most part, I'm going to keep this as it is. So it's going to generate the grid around the center of the point. So the hide and seek starter, we've got a target point there. That's where it's generating it from. We're going to keep that. That's okay. We're going to make sure that whoever's querying this, so the NPC, they can still reach that point. We're going to keep that one. But we're going to change this trace one here. Because at the moment, this checks if the player can see it or not. And that's where they'll hide. So it's going places where the player can't see them. We're going to change this from the player to the actual hide and seek starter. So when the game first starts, we're not going to make him check new points. So at the moment he can't see behind that wall, but he can see here. He'll run around here. He can see here now, but he can't see around there. We don't want that. We want it to be one snapshot of everywhere he can see, and that's where the player's going to search for. So in this instance, we can see this here. If I were to remove this block, he can't see there anymore. We're not going to handle that. This is going to purely be wherever the game starts. That's where they're going to check. Almost not real time. If you want it to be real time that you can move obstacles, that's going to be a little bit different. But for this basic example, it's going to go from the hide and seek starter and it's going to make sure it can hit it. The next one is the distance to. We're going to make him typically filter by only going where it's furthest away. You don't technically have to have that one, but I think most NPCs, if they're stood randomly, will probably look around and go, where's the most likely place they're going to hide? Probably the furthest away, because nobody's really going to hide, around a column directly watching you. You can, and you can modify that behaviour if you want to, but that's what I'm going to do in mine. So they're really the main changes we've got to do. There's one big one that we've got to do now, and that's how we add the memory into it. So when he runs and checks this one, he remembers that he's already checked that one. So there's a couple of ways we can handle this, but the way I'm going to do it, I'm going to open up our hide and seek AI controller, and I'm going to put it on here. It is only going to be temporary because when I massively revamp my AI system, I'm going to be using payload data and fragments to handle storing data. But for now, we can just stick it on here. So on here, I'm just going to add a new vector array called searched locations. and I'll set this to a type of vector, and I'm also going to right click it to turn it to an array, just so we can store a multitude of locations, because we're going to build it in a way where it can search a small area or a massive area. Then I'm going to add another one here, which we'll use later, called b is hiding, and I'm going to set this to a boolean, and I'm going to make it a singular, and I'm going to leave it unticked for now, because what we're going to do on our state tree is go based on this to whether they should be hiding or seeking currently. You can, of course, if you want them to check specific areas, not use searched locations and instead use, say, target points you put down. So you put a target point over here. I'm going to make it really dynamic though, so as long as the EQS query says it's a hidden area from the beginning of it, they will go and search it, because I think that'll be quite cool. And when we have the whole perception system in, it doesn't really matter where you hide, they're going to find you eventually. So now that we've got this here, what we need is a way in our EQS system to grab that vector array and say, hey, ignore nodes that are within this region. Let's use this one this time because I keep using the other one. If we store this node right here, this vector, and we say ignore all the nodes around this area, it will completely blank them out, and then the AI won't even consider searching those. And it's super simple to do. So all we're going to do is come to our EQS folder, and I'm just going to duplicate, say, the player one for now, but we are going to change it. And I'll call it env context search locations, and I'm going to open it up. And then instead of provide single actor, I'm just going to delete that off, and instead I'm going to override the provide location set. I don't know why they've called it a set. It's not actually a set. It is indeed an array. A set is something very different, but it doesn't matter. So now that we've got that, from the query actor, we can get their AI controller. At the moment, I'm just going to cast to the hide and seek. Typically, if you're using this search locations, you're going to load this hide and seek in memory anyway, so it's not too bad. But as I said, I'm going to be revamping how I hold temporary data eventually, so for now it's going to be okay. And then from here I can just do get searched locations, and I can plug it in over here. And then from the cast failed, we technically are going to be better returning something, even if it's just nothing at all. But one nice little feature I like to do for us to help debug it is from this result location set, I'm going to promote it to a local variable called debug locations. And this just means when we're testing the EQS system, we can set this locations here, and because it's not going to cast to this AI because it's in the editor, it'll be completely fine, it'll use this. Otherwise, in the game, it will cast it properly and use that one. So back on our EQS here, we can now add a new test of distance, and then we want to filter out anything we're not allowed to use, so places they've already been. We're going to keep it distance 3D, because then that means if you're going uphill, he will also filter out those ones and check them properly. The environment context is going to be our new searched locations. The filter type is going to be minimum, and I'm just going to set it to something like 800. And what this is back on these nodes here, let's use this one. If we specifically run to this node here, the vector is going to be that exact point right there. But we already know that none of these nodes contain the player either, because we can physically see it. So instead, that 800 or 500 is how big of a radius they need to remember. So 800 for me pretty much covers this corner off right there. It'll ignore all of those. Same with this corner over here. If you do have a hiding place where, for example, see if I can somewhat demonstrate it and give this a wiggle, like this, where you can hide in this spot, but not that spot, you're going to want to play with the range a little bit to make it work. For me, and like the Dishonored example I'm doing, it's quite a large radius, so you really only get 1 or 2 hiding spots in a big area, essentially. So set that to 800 or 500, you'll have to play with it. And the easiest way to play with it is to just drag it in. So let's drag the seek player in, and just make sure you drag your EQS and your target point up a bit, because we're dealing with 3D as well. If it's in the floor, it can't do it properly, and then it should update like so. If I come and move this over here, you'll notice none of the green nodes changed, because that's not what we're doing. We're testing from this target point and saying where are the hidden spots from here. The NPC seeing the player will be handled in the AI perception next time. So for the most part, that's the EQS system part done. Now we can move on to the state tree part and actually make it handle the seeking part. So in here, in our existing state tree, we have a condition saying is hiding. At the moment, it does nothing, but we actually have already made this condition. So if we just enter a condition of boolean compare or bool compare, we can set it to our new AI controller is hiding, and it must be true. So only if that condition is true should they start the hiding procedure where they run to a point, wait for the player to see them, then run away. However, we're now going to select the is hiding and add a child state of is seeking, where we're going to do the exact same condition but reversed. So bool compare, it will be the is hiding and it'll be false. So only if they're hiding. And then we actually need to almost do the same run to random point we've got, where we've got the move to EQS, but we need to change the EQS and some of the logic on how it handles it. So let's go and find that task where we've got move to EQS hide from player. And I'm just going to rename it to move to EQS seek player. I'm going to open it up. Inside here, when we enter the state, the first thing it does is run our new seek player EQS query. When it finishes running it, it gets the first location it needs to, and it will run to it, and then it will succeed or fail, right? However, I'm going to change how this works slightly. So the first thing I'm going to do is actually make them remember that they ran to this location. So just after when they run to the location on the async part here, I'm actually going to get the AI controller by passing it into here. So we'll do AI controller, and I will set this to our hide and seek controller. Pass it into the input, and now we can drag it in, and I will do get searched locations, and we will simply do add, and I will connect it to the async part and connect the get to there. So now every time they run to a location, they're going to remember it. We can technically also clean this up a bit here just by passing that into the controller, but it's just tidy up really. So another thing we're going to add into this one is we actually need a way of saying whether they've reached the area, whether they can't reach the area, or they've ran out of areas to find because the EQS query is not returning anymore. So how can we handle that then? Because typically a task only has a success or a failure on here. Well, we can use in the new Unreal 5.6 the on delegate parts, where we can trigger specific transitions. So back on here, instead of calling finish task here, what we're instead going to do is drag off and call broadcast delegate instead. And I'm just going to promote the dispatcher to a variable, and I'm going to call it on all areas searched. And we'll just hit compile and save. And what that'll do is now when you come back to your state tree, if we just add a child to this is seeking called run to random search point, and we'll add our task to it of seek player. I'll make sure I tick both actor and AI controller. And then one last thing I forgot is to just make it instance editable. Hit compile and save. It doesn't need to be part of input. You'll see we now have this new delegate dispatcher here. So we can specifically plug into it and say, if you finish successfully or failure, do these transitions. Or if this delegate is called, transition out anyway, and it will automatically finish the task. So on the transition here, we'll just click add. We'll go to on delegate, and you'll see we'll be able to now select this new on all areas search delegate, and we can specifically tell it to go to a specific area. So what I'm going to do is just add a new child state in here called all areas searched, and I'm going to transition on here to that all areas searched, like so. And this can just do anything essentially. So what I'm going to do for now, until we start adding dialogue, is just say I want them to run all the way over here essentially. So I'll drag a basic actor in, and I'll copy the location and delete it off. And back on here, I will add a task of move to, the built-in one, and I'll just paste that in, and then click the AI controller. So if all areas have been searched, they're simply going to go from there and run all the way down to here and basically stop. That's all they're going to do. We could even be a bit smarter. We'll add another state called all areas have been searched. We'll drag this all areas searched inside of it, and I'll call this move to finish area. And then we will retransition it over to that one. Because now it gives us the ability to simply call this, which will go inside here, move to the random area, and then we can add another child state where we just say, wait. And this will all they'll do. They will just stand there, I don't know, for 90 seconds, for example. And we'll just make sure this has got a transition to go to the next state. There we go. It means they'll stop, they'll run down here, and they'll wait here, ready for us to do whatever when we get to that part. It's just temporary code. So, if all areas have been searched as called, they will jump to this one and run these. That's all good. But what happens if they actually reach the point they need to get to? So they've reach this point here, they need to look around, essentially, because that's what most people do. They don't just run up and go, not here, and run off. They'll run over here, they'll take a look around, maybe look under a desk or whatever, something like that. We can get really advanced with how they look around. For now, we're just going to make them wait until I get some proper animations we can use. So, I'm just going to come and create another child state inside is seeking, and I'm going to call it is searching area. I'll put this under the run, because the run should always be the top one. And inside is searching area, I'm going to add a child state of looking around. And for now, like I say, it will just delay. If you do have some animations, you can call play montage. So I'll just make them wait for 5 seconds in that area. And then back on our run to random search point, we'll add another transition saying when this state is succeeded, they will run to the is searching area where they'll look around. Then it will jump back up to the top, come back down to is seeking, run to a random search point again, because they've already cleared off that area, and then they will come back to here until they've run out of areas, and it will jump down here. Looking really nice so far. However, we do technically have a fail point in our task, which is specifically if the player is blocked for some reason, say the NPC can't get through to a gate, even though it's saying they should be able to. For that, I'm not too worried. I'm just going to let it finish the task unsuccessfully, but we print something out anyway. So in theory, we could possibly try this now. So if we just tap play, you'll see that AI is going to run to this area here, and he's going to stand there and wait. He's looking around now to see if he can find the player. And then the 5 seconds are up, he's now running to a new location. And he's going to look in this one. And now he should have remembered that he searched that one. So he's going to run to another location, which is the one round here. There we go. And now finally, he's only got one more location he can search, I believe. Yep, he's searching the final one, so it's looking good. He's looking for the player now. And he's running in here. He's having a quick look around, saying, nope, not here. And then I believe he should now finish. There we go. He's finished because he can't find anywhere to go. It did print out. You'll see he's going to run down here and just stop. He's searched all available locations. That's where you can start your dialogue saying, okay, I can't see you, come on out, or whatever you want to do. So for now, we can add a super basic thing in so that it fires a line trace to check for the player. Super, super simple to do. And it is only temporary code just so we can progress along now. But all I'm going to do is come and create another task inside here. A blueprint class, and it'll be a type of state tree task. State tree task blueprint base. We'll call it STT underscore search for player. And we'll keep it like this because we will replace this with AI perception in the next episode. But for now, I'm just going to go to on tick in here, and I will drag off and sphere trace just so it's got a bit of leeway. And I'm going to do by channel. I'll set the radius to something like 20. It doesn't really matter hugely. And then I'm going to pass in the NPC like we normally do. So I'm just going to cheat and copy it from this one. There we go. We'll get their actor location and we'll pass that into the start point. We're going to get the player, so get player pawn. We'll get their actor location and pass that into the endpoint. For now, I am going to debug this for 5 seconds just so we can see that they are actually searching. And then I'm going to make sure actors to ignore I will make and just pass the NPC into it like so. If they get a return hit because they hit the player, and I'm going to break on the out hit here, we've got a blocking hit, so just a double check. And then finally, I'm also going to double check if they equals the get player pawn, so they're not seeing another NPC. Only then, you could technically wrap this in an and if you want to, but it's test code. Only then we know we've spotted the NPC, right? So we're just going to call broadcast delegate again, where the dispatcher will promote to a variable on player scene, and we'll hit compile and save. Make sure it's instance editable. You might be wondering why are we not calling finish task there. I'll explain that in a short moment. So this task here is going to tick every frame, but we'll adjust that in a moment, to search for the player when they're in the searching location. Just make sure in class defaults your ticking should tick only on events, otherwise it won't work. And then back on our state tree, when they're looking around in here, we're going to wait 5 seconds for them to look around, right? That 5 seconds is going to return true when it's done. So that will call finish task. And that means they'll go back up to root, right? But we're going to add another task inside here of search for player. And we need to pass the NPC as an input category. Forgot to do that. So input. and now we can pass the NPC into it, and we've got our delegate. This just means that we can now take this delegate and transition to we found the player, which is a nice way of doing it. You could technically return false, but I figure the delegates are a bit more obvious in what's happening. It makes more sense. And the clever way this is going to work is this search for player is never going to finish, ever. That's the point of it, unless they physically see the player, where the delegate passes on. So the only way this is going to work is if this node up here is set to any, and you can technically untick this if you want to. There's 2 ways you can do it. And what this means is this says any of these tasks in here, whether you've got 1 or 50, if any single one passes, every single one is complete, it moves on. However, if it's set to all, then every single one has to complete. So we're going to keep it set to any, and we're actually just going to untick that. It will simply mean that this task isn't counted towards it. You don't need to do it. It does the same thing as setting to any, but it's just an obvious thing for the people to see if another developer comes onto it. So this delay will always wait 5 seconds, but they will constantly search for the player. If at any point in those 5 seconds it sees the player, it will call the delegate where we can transition to another node, which is cool. So inside this searching area, I'm going to add a child state of player found. And inside here, I will just add a child state of run to player. Because obviously, if you see someone, you're going to run up to them. We'll add a task of move to. And the AI controller is that one. The target actor, we need a way to actually get the destination or the target actor of where the player is from. So we can actually do this with another task instead of creating a whole nother move to task. So I'll show you this because it's really cool. I'm just going to duplicate one of these tasks called STT get player's location. I'm going to open it up. I'll delete everything off of here and make sure it's not ticking. And only on enter state, we're going to get the player pawn. We're going to get their actor location. And then I'm going to promote this to a variable called player's location, right? And I'm going to set this to an output. And I'll delete the other 2 off because we don't need them. And then from that, I will simply call finish task. You could, of course, put this on event tick if you want them to chase the player. I'm just going to say as soon as they see the player, they'll run towards them. But because we've set it as an output, on our state tree, we can now come in here and add another task to it of get player's location. I'll make sure it runs above this task, so it runs first. And because we've outputted it here, you will see in this destination, we can now get the player's location from the other task. How cool is that? And just like we said before, this task is going to finish, but we don't actually want it to finish until we run to them. We're going to untick it there so it doesn't count towards finishing the task. You could, of course, also put all and tick both on. Both are acceptable ways of doing it. So once they've run to the player, what do we want them to do? Let's add a sibling state, mock the player, I guess, where we can just make them stand there for, I don't know, 90 seconds mocking the player. Haha, you lost, blah, 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 blah. And on the run to player, when the task is completed, because they've run towards the player, we will just go to the next state, which we mock the player, and we'll hit compile and save. So now we've got a pretty decent system set up. We do need to change looking around on here. So back on our transition, let's add our new on delegate for our search for player on player scene. We will jump them to player found, and we'll hit compile and save. So I hope that makes sense. It is a bit more compared to what we've done for the is hiding, but if you break it down nicely, it does make sense. We can even come and color code it now because they've changed it, which is quite nice. So we can come and add new colors in. So game over, and we'll set it to red because game over. And we'll set this one to be game over. There you go. So that's a horrible red. Let's try that again. Yeah, that's much better. There we go. See, you can just make it look a little bit nicer. It doesn't affect the game at all, though. So in theory, we can now test this. There is one critical flaw that I will point out shortly. But you'll see that if we run and hide behind this wall, when he searches for us, the line trace is hitting the wall, so he can't see us. So you'll see he is completely ignoring us. He's now running to the next one, I think. Yes, he's run over there and he still can't see us. But if we make ourselves visible, look, he's running towards us because he's found us. And now he's going to stand there and mock us. Ha ha ha, you lose, I found you. Great. You do see that the big critical flaw is, look, he can see me right now, but he can't see me. So if I hide here, and we'll fix this mass sphere trace thing in a moment, you'll see he can't see me, but look, he can see me, but he's not doing anything. That's what we're going to solve with the AI perception next episode. But for now, this is a very basic implementation. Final note, just to fix the mass amounts of the sphere trace spamming, because we obviously don't want that, because event tick isn't bad if used in the correct way. We're using it in the correct way. So all we're going to do is tune it down a little, because at the moment it's running once every frames per second. So if you're running 60 frames a second, it's running 60 times every second to spot the player. The player physically can't move 60 times that quickly. If you're running 30 frames per second, it's running 30 times, it's running less, but still. So what we're going to do is when we're looking for searching for player, we're just going to come in and set the custom tick rate to something like 0.5. So it searches every half a second. And you'll see this time when it runs up to there, it will be a lot less. Boom, 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 boom. See, a lot less. Much better. And you'll see he'll run out, he can't see us. And if we were to stay hidden for the longest time, make sure he doesn't see me out by accident. He's going to run to a new area. Where's he gone? He's there. Look, oh, we nearly searched us then. We're just going to wait for him to run away. He will run to the next one. Then, in theory, he shouldn't be able to see us. Oh, he was close, though. And now he should finish the game and run to the ending. I can't find anywhere to go. There you go. So he's lost us. How cool is that, ladies and gentlemen? So that is part 2 of the hide-and-seek system where the player is hiding. Like I say, in the next episode, we're going to add proper AI perception to him, so he's always searching for you. If you run across the battlefield in front of him, he's going to spot you. But if you run behind him, he won't see you, which will be very, very cool. After that, we're going to look into adding some more polish to it. We'll add some dialogue. We'll add some way of starting and stopping it, flipping roles. If you do want to flip the role, you simply just come and set the is hiding to true, and he'll do the other part of the state tree. So you click play, you see, he's now going to hide from us. That's it. Super simple. But yes, thanks for watching, ladies and gentlemen. I hope that was helpful. If you've got any improvements or suggestions for other tutorials, please let me know. My name is Decryption, and I will see you next time.